So this is area 1, how to solve for a rectangle. This was our first area. This was our first part of the Texas equation. So what we're going to do here is we're going to go ahead and do width times length, which is going to be 2.8 times 1.8, which is going to be equal to 4.14 squared. That's the area. Area equals 4.14 squared. That is the area of the first rectangle. Okay, so this is area 2. Again, utilizing Heron's theorem. We took a step back from area 3. It was just the order was a little bit messed up. Same thing though, same deal, triangle. So we're going to use, of course, as I said before, Heron's theorem again. So we're given A, B, and C. Plug that in to solve for S. 5 plus 3.4. And when we plug that into the calculator, we should be able to get S. So once we get S, we can then go ahead and plug it into the area formula and then solve for the area. So 2.3 plus 2.5, which is B, and then plus 3.4, which is C, is going to be 8.2, as you can see on the calculator right there. I'm going to divide that by 2, 4.1. So S is equal to 4.1. Now we're going to do this area is equal to, well, let's do a little a so we don't get confused. Square root of 4.1, which is S, 0.1, 4.1 minus 2.3, 4.1, I'm going to go off the screen here, 2.5, and then 4.1 minus 3.4, 3.1 minus 3.4. Okay, so all of that under a square root, and then we are going to be able to solve for the area of this triangle, of this specific triangle, of this proportion, not of this proportion, but of this certain area of Texas. So once we plug that all into the calculator, we are going to get the square root of 41. Let's go down, or 4.1 rather, of 4.1, 4.1, and then quotation 4.1 minus 2.3, 2.3, and then 4.1, which is A, and then 4.1 minus 2.5, which is B, and then 4.1 minus 3.4, and that should give us area is equal to 2.875 squared miles. Okay, awesome. On to the next one. Okay, so my last video got cut off, but where we were was we were finding the area of the second triangle technically. So the second triangle, the equation that we are going to use is going to be Heron's theorem, and Heron's theorem states that S equals A plus B plus C divided by 2. Therefore, the area is equal to the square root of S, apostrophe is S minus A, S minus B, S minus C. So we plugged it into the calculator, and through the calculator we found what S was, and S was, you can see right there, 3.2. So now that we found 3.2, we are plugging it into the original, the equation right here to find area. So what we're going to do is 3.2 minus A, which is 1.8. 2 minus 1.9, and then 3.2 minus 3.2, or 2.7. 2.7. Once we plug that all into the calculator, we should solve for the total area. So let's go ahead and do that. So the area, if you can see right here, is going to be the square root be the square root of, let me just plug it in, 3.2, comma, 3.2 minus 1.8. So we're getting all the sides in here, A, B, and C. 3.2 minus 1.9, which is B. And then 3.2 minus 2.7, which is C. And if you can see right there, that is what our square miles is going to be. Before, of course, we put it into the ratio in terms of the map and the scale at that level. So 1.706 square miles. All right, so that is the second area second triangle, third area. All right, we're going to now solve for triangle 4 or triangle 3. And again, we're going to use Heron's theorem. So if we use S equals 1.9 plus 2 divided by 2, we are going to get 2.95. If we plug that into the calculator. And then we are going to get A, if we plug this in to find the area, now that we have S, into the theorem, we are going to get 2.95 minus 1.9, 2.95 minus 2, 2.95 minus 2.95 minus 2, all that square rooted, and plug that into the calculator. We are going to get area, total area, is going to be equal to 1.672 squared miles. That is for triangle 3. Hey there, so we're solving for yet another triangle. This is going to be triangle 5, or triangle 4 technically. So we can go ahead and get started with Heron's theorem again, the typical theorem we're going to be using throughout this entire project, because our entire project is composed of only triangles except for one rectangle. Now if we plug that into the calculator, we're going to get S is equal to 5.1. And now the total area, we plug it back into the formula here in order to solve for area. 5.1 minus 2, 5.1 minus 3.4, 5.1 minus 4.8. So if we plug that entire equation into the calculator, we are going to get the area is equal to 2.840 squared miles. And that is the area for triangle 4 or area 5. Alright, so this is the area for triangle number 6. Again, a triangle, so we're going to use Heron's theorem. So we're going to start off for solving S. It's going to be 2.7 plus 4.8 plus 5, all that divided by 2. And you can see right here I have S is equal to 6.25. Now we're going to plug that into the formula to solve for the area. So 6.25 minus 2.7. Sorry for the background noise there. 6.25 minus 4.8. 6.25 minus 5. All of that square rooted. We are going to get the area, the total area, is going to be equal to 6.475 squared miles. That's going to go into the total. So that's the area of triangle 6. Hey there, so we're solving for area 7 right now, and area 7 is again a triangle. This was the only rectangle that we had in the entire map, and the entire findings. All the angles that we found, or the shapes that we found rather, were all triangles except for one rectangle. So area 7 A equals 1, B equals 5, C equals 5.6. So if we want to plug this into the Heron's theorem equation again, we can do S equals, and it's going to be 1 plus 5 plus 5.6 divided by 2. You can see right here I've got 5.8. So S equals 5.8. We'll plug that into the equation. It's going to be 5.8 minus 1, 5.8 minus 5, and then 5.8 minus 6. Minus 5.6. Now, if we plug that into our calculator, we are going to find that is equal to area is equal to 2.111 squared miles, and that is the area for triangle number 7. Hey there, so this is the to find the area for triangle number 7, or triangle area 8, triangle 7. So what we're gonna do here is again Heron's theorem. So to solve for the area, so we're gonna do 3.5 plus 5 plus 5.4, all of that divided by 2. That's gonna be equal to S equals 6.95. Now we're gonna put that on the square root in order to solve for the area, right? So we're gonna do 6.95 minus 3.5, 6.95 minus 5, and 6.95 minus 5.4, all of that under a square root. And once we get the square root of that, we are going to finally be able to solve for the area. So 6.95 minus a, which is going to be 3.5, and 6.95 minus 5 right here, which is b, minus 5, which is b, and then we're going to do 6.95 minus 5.4, which is c, and we'll just plug that all in. We're going to get 8.513 squared miles. And that is the area for area 8, triangle 7. Alright, so this is to solve for area 9, triangle 8. So we're going to use, again, it's a triangle, so we're going to use Heron's theorem. So which would be a plus b plus c, which is going to be 2.5 plus 4.5 plus 5.4, all of that divided by 2, which is s, 6.2, right? So, and then we're going to put it into the square root in order to solve for the area. Minus 2.5, 6.2 minus 4.5, which is b, and then 6.2 minus 5.4, and all that square rooted to get the area of that. Plug it into the calculator. It's going to be equal to area equals 5.586 squared. And that is the area for number 9, triangle 8.
To calculate the square mileage of Texas, we used Heron's formula. Heron's formula can only be applied to triangles, and so we split Texas up into 18 different triangles and 1 rectangle. In this diagram, variables A, B, and C represent the 3 side lengths of a given triangle, and variable S is the perimeter, area 10. Area 11. Area 12. Area 13. Area 14. Area 15. Area 16. Area 17. Area 18. Area 19. Basic information, scale, and formula. Process. Total area. After adding each individual area and applying a ratio of 76.321 to each area, we came to a total area of 264,645.13 miles. Accuracy.